Welcome back to Mr. Vaughn's Classroom. Please hit the subscribe button and give this video a thumbs up. Today we're in Unit 4 on functions, looking at Lesson 17, writing inverse functions to solve problems. Our learning goal today is to use inverse functions to solve problems. We have two learning targets today. As we go through the practice problems, keep these two learning targets in the front of your mind. And if, at the end of the lesson, you don't feel comfortable making either of these statements, please drop a comment below, and I'll get back to you with any clarification I can offer. Learning target number 1, I can write a linear function to model given data and find the inverse of the function. In other words, if I know the y-intercept and I know the slope, can I write the linear function that models that? And then once I find that linear function, can I find the inverse by rewriting it so that the original input becomes the new output and the original output becomes the new input? Learning target number 2, when given a linear function defined using function notation, I know how to find its inverse. In other words, if you're given the function notation and it shows you the input and it shows you the output, do you know how to rewrite that so that the original input becomes the new output and the original output becomes the new input? We have one glossary term for this lesson, and that is inverse function. Two functions are inverses to each other if their input-output pairs are reversed, so that if one function takes A as input and gives B as an output, then the other function takes B as the input and gives A as the output. You can sometimes find an inverse function by reversing the processes that define the first function in order to define the second function. Now we begin the practice problems for Unit 4, Lesson 17, writing inverse functions to solve problems. Number 1. The table shows the value of a car in thousands of dollars each year after it was purchased. Plot the data values and find a line that best fits the data. So the first thing we're going to do is just simply plot the points. We have 0, 30. So we start at the origin, we go up to 30, and we put our first point. Then we have 1, 22 and a half. We go over to 1 and up to 22 and a half. Then we have 2, 19. We go over to 2 and up to 19. Then we have 3, 16. We go over to 3, up to 16. Then 4, 13 and a half. Over to 4, up to 13 and a half. And finally, 5, 11.4. So we go over to 5 and up to 11.4. Now that we've plotted the points, what we can do is use the Desmos calculator to find the line of best fit. To do that, you come into the desmos.com/calculator. You hit the plus sign up here in the top left, and you choose table. It'll give you an XY table, and you fill in the values as I've done here. Once you have all the values put in, you can see that it plotted the green points. And now we hit this icon to the left that looks like 4 dots and a straight line, and it's titled Add Regression. When you do that, it will put in your line of best fit. And if we look at it, it looks like we cross the y-axis at about 27.5, and we cross the x-axis at about 7.8. So 27.5 and 7.8 come into here. And we add our line of best fit. So that takes care of number 1. Number 2, write an equation for the linear function c that gives the value of the car in thousands of dollars when its age is t years. So what we can do is write c of t equals, and if we go back to that Desmos calculator, right here for equation, it tells us what it is. I'm going to round to 1 decimal since that's the most decimal places we have in the points that we were given. So we have negative 3.5 x. So in this case, we're going to replace the x with t. Plus 27.5. And this is the equation. Number 3. What does c of 6 mean in this situation? And what is the value of c of 6? So the first thing we're going to do is explain what c of 6 means. Well, 6 is the input, and that was t, and the t represented the vehicle's age. So c of 6 represents, or is, the car value after 6 years. And then they want to know what that value actually is. So c of 6 equals negative 3.5 times 6 plus 27.5. And when we put that into a calculator, negative 3.5 times 6 equals negative 21 plus 27.5 equals 6.5. And since that represents thousands of dollars, c of 6 equals $6,500. Number 4. In this situation, what does the solution to the equation c of t equals 2 tell us? Find that solution. So this time they're telling us what it equals, but they're not telling us the input. This means the solution would be the age at which the car value was $2,000. So C of t equals 2 will tell us the age at which the car is worth $2,000. Now they want us to find that solution. So what we can do, if c of t equals negative 3.5 times t plus 27.5, then we can set these two equal. First, we would subtract 27.5 from each side, and that would give us negative 3.5t equals negative 25.5. Next, we would divide both sides by negative 3.5. And that would give us approximately 7.3 if we round. So 7.3 years. This is the time when the car would be worth $2,000. On number 5, it says write an equation that would allow us to find the age of the car when we know c of t. What they're asking us to do here is find the inverse function. Rather than c of t being the output and t being the input, they want us to rewrite it so that c of t is the input and t is the output. So what we're going to do is take the original equation that we found in red, c of t equals negative 3.5 times t plus 27.5. Now, we're going to subtract 27.5 from both sides. Now we have negative 3.5t equals c of t minus 27.5. And the last thing we need to do is divide both sides by negative 3.5. And that gives us t equals c of t minus 27.5 over negative 3.5. This is now the inverse of the equation that we wrote in number 2. All we did was rewrite it to solve for the opposites. Number 6. Use your equation to estimate the vehicle age when the value of the car will be $500. The reason that we find this inverse is that now we have an equation where we can substitute the value of the car as the input and because this is thousands of dollars, we're going to write $500 as 0.5 minus 27.5 divided by negative 3.5. 0.5 minus 27.5 would be negative 27. And negative 27 divided by negative 3.5 is approximately 7.7. And we're measuring the vehicle age in years, so that's 7.7 years. If you have any questions about any of the parts from this practice problem, please drop a comment below and I'll get back to you with any clarification you might need. Our next practice problem says, the distance d in kilometers that a car travels at a speed of 80 kilometers per hour for t hours is given by the equation d equals 80t. Number 1. If the car has gone 120 kilometers, how long has it been traveling? So in number 1, they are giving us the distance, which is the output, and they are asking us to find the time, which is the input. So we substitute 120 in for d, and now we need to solve for t. We would divide both sides by 80, and 120 divided by 80 is 1.5. So this is 1.5, and since we're talking about t, and t is in hours, t equals 1.5 hours. Number 2 says rewrite the equation to represent time t as a function of distance d. So what we can do is take the original equation, d equals 80 times t, and in order to get t by itself, we would divide 80 on both sides. And now we have an equation that is written to solve directly for time, using distance as the input. This is the inverse of the original equation that was given to us. So by knowing how to write the inverses, we can set up an equation to solve for either variable as the output when we know one of the variables as the input. If you have any questions about this practice problem, please put a comment below and I'll get back to you with any clarification you might need. Our next practice problem says, match each function on the left to its inverse on the right. To do this, you're going to do the opposite to each side. So on A, the first thing I would need to do is the opposite of minus 3, which would be add 3. Then, to get rid of the 2 from the 2x, the opposite of 2 times x is divide by 2. So if we look at our choices on the right, we now want to find one where we have y plus 3 divided by 2. And the only place we have that is number 2. So A matches number 2. Our next option is B. We have y equals 3 times x. The opposite of multiplying by 3 is to divide by 3. So when we look at our options on the right, we're looking for x equals y divided by 3. We see that on number 5. That means B matches number 5. Next, C says y equals 3x minus 2. The opposite of subtracting 2 is adding 2. So our first step would be to add 2. Then we have 3 times x, and the opposite of multiplying by 3 is divide by 3. So on the right, we're going to look for y plus 2 divided by 3, and we see that on number 1. So C matches number 1. Next, we have D. D says y equals x minus 2. The opposite of subtracting 2 is adding 2. So on the right, we're going to look for y plus 2. And we see that on number 4. So the inverse of D is 4. Next we have E. Y equals x plus 2. The opposite of adding 2 is minus 2. So we want to look for y minus 2. We see that on number 6, so the inverse of E is number 6. And finally, we have F. Y equals x minus 2 divided by 3. The opposite of dividing by 3 is multiplying by 3. Then The opposite of minus 2 is adding 2. So we want to look for y multiplied by 3 plus 2, and we see that on number 3. So the inverse of f is number 3. You find the inverse by doing the opposite of what is there to both sides and setting up the equation so that the original input is the new output and the original output is the new input. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with any clarification that you need. Our last practice problem says functions h and j are inverses. When x is negative 10, the value of h of x is 7, or h of negative 10 equals 7. Number 1 asks us, what is the value of j of 7? So here's what we need to understand. If they are inverses, then the input-output pairs for one are the opposite for the other. So to diagram that, if I have h of x and the input equals negative 10, then on j of x, the output would equal negative 10. And on h of x, they said the output was 7. That means on j of x, the input would equal 7. So to answer their question, what is the value of j of 7? The answer would be negative 10. We simply take that input-output pair and we swap it. Number 2, determine if each point is on the graph of h, on the graph of j, or neither. Explain your reasoning. So for number 2a, we have the point negative 10, 7. Well, that matches h of x because the input equals negative 10 and the output equals 7. And that matches exactly what we saw on h of x. For 2b, we have 7, negative 10. Well, that one is going to be on the graph of j of x because the input is 7 and the output is negative 10. And that matches exactly what we found in number 1 for j of x. If you have any questions about any of the practice problems we did here on Lesson 17, please drop a comment below and I'll get back to you with any clarification that you might need. To finish out this lesson, I want to review our learning targets. Learning target number 1, I can write a linear function to model given data and find the inverse of the function. So if you feel comfortable with being able to use the Desmos calculator to find your line of best fit, and then use that to write the linear function, and then understand that you simply want to rewrite it so that the input of the original becomes the output of the inverse, and the output of the original becomes the input of the inverse, then you're right where you should be. Learning target number 2, when given a linear function defined using function notation, I know how to find its inverse. So if you are able to look at function notation and understand that what is in parentheses on the function notation will be what the inverse equals, and what the function notation of the original says it equals will become what is in parentheses for the inverse, then you're also right where you should be. If you have any questions from this lesson, please leave a comment below. I'll get back to you with any help you might need. I ask again, if you found this video helpful, please subscribe, give this video a thumbs up, and I look forward to seeing you in the next lesson.